Jai Hind officers, ladies and gentlemen. Today, we review the most significant leap in air power since the jet engine, the transition from contemplating unmanned systems to executing autonomous warfare. Actually, we are no longer contemplating the future of unmanned aerial systems. We are living in it. In the next 15 minutes, I will outline how the unmanned aerial system has fundamentally altered the strategic calculus of conventional war. I will also throw light on operational employment of UAS in contemporary conflicts with emphasis on strategic implications for air power and future force structuring. I will be covering this topic under following heads: the strategic leap, where I will emphasize on the last decade of disruption. Then I will brush upon few case studies, followed by the strategic lessons and key takeaways before I conclude. In the last decade, we moved through three phases. It started with unmanned aerial system as support in the Middle East, moved to system-level holdovers in Nagorno-Karabakh, and have now reached the strategic asymmetry in the Ukraine and US-Iran conflicts. Also, in the last decade, we have witnessed a fundamental collapse in the traditional barriers to entry for aerial warfare. What was once the exclusive domain of wealthy nations, the ability to strike from the air, is now accessible via a laptop and a VR console. We have moved the unmanned aerial system as support assets to primary effectors. We are witnessing fundamental shift. The unmanned aerial systems are no longer niche enablers but center to air operations. Their proliferation has lowered the threshold of effective air power even for non-state actors. Let us now brush through the case studies, starting from Nagorno-Karabakh till the ongoing US-Iran conflict. The 2020 conflict in Nagorno-Karabakh was a post-modern turning point. For the first time, unmanned systems overwhelmed a conventional ground force. They systematically decimated air defenses, tanks, and supply lines. This conflict demonstrated that relatively low-cost UAS, when employed in a coordinated manner, can neutralize high-value assets, including air defense systems. Major example to quote is the Azerbaijan systematic destruction of Armenia's S-300 air defense system and T-72 tanks. Gentlemen, the 44-day war was a warning. Armenia's formidable Soviet-era air defense was not outfought, it was out-evolved. The Harrow loitering munitions acted as autonomous hunters, loitering for hours to detect radar emissions and then diving with surgical finality. By the time the ground offensive began, the Armenian armored corps had already been hollowed out from the air. In this theater, RPAs like Bayraktar TB2 acted as the ultimate target acquisition hubs. They moved beyond symbol reconnaissance to becoming the primary coordinators of the kill chain. By using high-definition electro-optic and infrared imageries, they identified Armenian S-300 batteries and T-72 tanks that were previously thought to be well camouflaged. Once identified, the RPA either designated targets for laser-guided munitions or directly fed the coordinates to long-range artillery. The battle damage assessment, the BDA, was instantaneous and televised. The high-resolution kill cam footage was used not for just operational verification, but as a potent tool of psychological warfare, proving that the unmanned aerial system saturated environment concealment is no longer a viable defense. Moving on, now that we are familiar with Harop and Bayraktar's success in 2020, let's turn pages to leap in Ukraine's Operation Spiderweb. By using $1,000 first-person view drones with AI terminal guidance to strike strategic bombers 4,000 kilometers away, the adversary has proven that strategic depth is a legacy concept. If an asset can be seen by a satellite or a commercial drone, it can be targeted by a SWAT. The Ukraine conflict highlights the scale of unmanned aerial system can be employed by a weaker nation. Ukraine's Operation Spiderweb redefined the strategic depth. They didn't use the $1 million cruise missiles. Instead, they launched attritable drones from mobile trucks parked near the target. With help of AI models, the drones were programmed to strike high-value soft spots like fuel seams and engine pylons. The result was 41 aircraft disabled or destroyed in a single night at a fraction of cost of one missile. This proved that even high-value assets like Tu-95 are vulnerable to $1,000 platforms. We are well aware of what happened during Op Sindoor. Leading up the operation, the critical phases of target identification and real-time validation was spearheaded by Searcher and Heron RPS. The high-fidelity SAR and EO imagery provided by these assets proved indispensable for both the acquisition and subsequent precision of destruction of the targets. Furthermore, the deployment of Heron Mark II enabled seamless dynamic BDA, providing senior leadership with immediate confirmation that the mission objective has been successfully addressed. Strikers were employed as executioners during the operation. They bypassed Chinese supplied air defenses completely and striking in just minutes. Defensively, we faced the counter-swarm. Our integrated air command and control system successfully synthesized data from Akshatir layer to intercept the Turkish origin EHA unmanned system used by the adversary, proving that the kill chain must be digital and instantaneous. Moving on, the recent US-Iran engagements provide a chilling look at the saturation warfare. We have all read about what happened at Tower 22. A simple tactical deception shadowing a friendly unmanned aerial vehicle defeated a multi-million-dollar defense grid. In the subsequent Operation Epic Fury, the US was forced to deploy the Maven Smart System. With this smart system, ISR platforms like MQ-9 Reaper and Globalock process thousands of data points simultaneously to identify mobile drone launchers hidden in the civilian clusters. The role of RPS has shifted from finding to filtering. This was the first time AI was used to compress a kill chain from days to seconds, processing 13,000 targets in weeks. While Iran used masked Shahid-class one-way attack drones, SOMs, to attrit Western air defense and strike strategic depths, the US responded with low-cost unmanned combat attack systems, or LUCAS, reverse-engineered attritable one-way attack drones designed to match the adversary's cost imposition strategy. This conflict has fundamentally shifted the baseline of modern war, proving that success now depends on the seamless integration of autonomous swarms, AI-driven targeting, and the ability to maintain mass in a high-attrition environment. The strategy lesson that can be culled out from this conflict is that the new normal in the battlefield is dominated by sensors. In modern conflicts, the role of RPAs has fundamentally shifted from a passive eye in the sky to the primary orchestrator of the multi-domain kill chain. In theaters ranging from the rugged terrain of POK to the electronically contested plains of Eastern Europe, unmanned aerial systems has proven that the persistence is the new air superiority. RPAs serve as a critical nodes for dynamic target validation using advanced EO, IR, and SAR imagery to strip away adversary's concealment in real time, thus updating the E-orbit of enemy. This unblinking stare does not merely help find the targets, but to enable high-speed decision-making, ensuring that the BDA is no longer a post-mission report, but a continuous, live-streamed operational requirement that dictates the immediate tempo of the follow-on strike. Let us now dive deep into the major lessons and the key takeaways by reviewing these conflicts. The primary lesson is the cost asymmetry. We are currently in a trap where we use $2 million missiles to shoot down $20,000 drones. This is mathematically unsustainable in a long-drawn war. The takeaway is that we must accelerate the induction of more quantity of hard kill measures, guns, and directed energy weapons, and soft kill measures like GPS jamming and spoofing. Our high-end MRSAM and S-400 magazines must be preserved for manned threats and cruise missiles. We need a cheap versus cheap ladder of force. However, the decision to engage which weapon depends upon the situation, the reaction time, and the likely target it is going to address. Going over the SEAD evolution, drones are now the primary tool for suppression of enemy air defenses. Ukraine and Iran have proven that the safe rear no longer exists. Air bases are now frontline targets. The takeaway is that we must pivot from static defense to resilient infrastructure. This means hardened aircraft shelters, hopping plan for assets, use of decoys, and most importantly, near-base pattern of life monitoring. We must treat a civilian truck parked near a base as a potential launch platform for a proximity attack. We must also ensure maximum information security. As far as training is concerned, the induction of weapon system branch in the Indian Air Force 2 years back and induction of UAS school, which was inaugurated last week, indicates that we are stepping in the right direction. Exercise like ITA and Akraman has seen employment of unmanned aerial system extensively, showcasing the offensive capability of the platform as well as reducing the sensor to shooter time. Moving on with AI integration, automated aim points and navigation are no longer optional in a GPS denied environment. The speed of a drone swarm exceeds the human OODA loop. In the US-Iran conflict, the only successful defenses were those where AI handled the detection and assignment. Takeaway for us is we must integrate AI-assisted target recognition in the IACCS. The sensor-to-shooter link must be autonomous with man in the loop before targeting. We need algorithms that can distinguish a bird from a drone and a friendly UAS from an adversary's shadow drone in milliseconds. Also, in a GPS-denied environment, terrain mapping, autonomous navigation play a crucial role. Sensor fusion capability with AI will enable faster processing of EO and SAR images, providing target details. One of the most important lessons is jointness and indigenization. Success in Ops Sindoor required whole of a nation effort and jointness of all three services. Remember, supply chains are the first casualties of war. In a high-intensity conflict, we cannot rely on imported spares. So the takeaway is we need mass treatability. We must foster a domestic ecosystem capable of 3D printing thousands of low-cost one-way attack drones. Our goal should be quantity as a quality, overwhelming adversaries' defenses through sheer numbers. This can be achieved by utilization of commercial drones or quadrocopters in the conflict with the help of civil-military fusion. Mer Baba drone competition is aligned towards the indigenous initiative. So far, unmanned aviation has been believed to excel at dull, dirty, and dangerous missions. The recent conflicts prove that it can carry out impossible and efficient tasks as well. In the future war, we must prepare for GPS-denied environments using AI-driven mapping and swarm logic. Our doctrine must pivot more towards employment of unmanned aerial system in offensive as well as air defense role. The leap is complete. The battlefield is now a sensor-saturated transparent dome. For the Indian Air Force to maintain its edge, we must transition from platform-centric force to a network-centric AI-augmented force. Operation Sindoor showed that we have the capability. The challenge is now to achieve the scale. Jai Hind.